So there was nothing that is particular to this example, except the size of our basis. We were working in R2, so we had 2 basis vectors. So this previous example gives us a general format for how to convert between coordinate systems. The only thing that changes is the number of vectors and the number of coordinates that are involved. Let's use script E with elements E1, E2, down to EM to stand for the standard basis for Rm with coordinates x1, x2, down to xm. So all of the points in Rm can be written as linear combinations of the EIs. If we have another basis, B, with elements V1, V2, down to Vm, and we label the coordinates y1, y2, down to ym, then we can convert back and forth between our 2 basis and coordinate systems using the following matrices. If we're given a vector, V, inside curly braces subscripted with B, which we think of as a vector in the coordinate system defined by B, having entries y1, y2, down to ym, then we can express this vector in standard coordinates simply by multiplying it on the left by the matrix whose columns are the elements of the basis. So this tells us how to take something expressed in the new coordinate system and convert it into our standard coordinate system. The process of going in the opposite direction is similar, but uses the inverse. So if we're given a vector expressed in standard coordinates, x1, x2, down to xm, then we can express this vector in the new coordinate system by simply multiplying this vector on the left by the inverse of the matrix whose columns are the basis elements. So this gives us the expression of our vector v in the new coordinates y1 through ym. In the next video, we'll talk about some reasons why we actually would consider using different coordinates than the standard ones.